approximation to a curve, we're going to approximate with a straight line. You think that your calculator does e to the x, it knows how to graph e to the x. It doesn't. It uses little pieces of tangent lines so small that your eye can't see that's what it's doing, because it's very easy for a calculator to calculate linear functions. Exponential functions, no. So when we do chapter 8, you're going to see we're going to be approximating functions with, well, linear and quadratics, but that's the application because we don't know how to do e to the x. So we do little tangent lines, and we will extend it. So your project will be really extending that idea, and that'll be due the 21st of December. So be warned. So I gave you a picture here. Write the slope of the tangent line as a function of x. I'll give you a second to do that. Write the equation of the line using the point f of a, f of a, that one right there. And then you're going to solve your equation for y. I do not memorize the formula that goes with this. Just a little formula. I see no pencils going. Okay. I think this is supposed to be. No, maybe not. So I'm going to put a point on my graph here. And it's a, comma, f of a. What's the slope between this point here and that point on my curve? So m equals what? F of a. I would prefer the y's first, but it doesn't matter. Over a minus x. Right? What's another way to call that slope there? F prime of a. You agree that I could do this? I could do y minus f of a over x minus a. Is that okay? Which is equal to f prime of a. Oh, well, that's how you get the equation of a line. Cross multiply. What do we get? By cross multiply, I get y minus f of a equals f prime of a times x minus a. Right? That's just the equation of a line. Same old, same old. Can I find the y value? Sure. And now what we'd like to do is, I know you probably want to add f of a to both sides and put it at the end. We're not going to do it. We're going to put it in the front. So y is equal to the value of the y function at a plus the derivative at a times x minus a. A preview of things to come, but that's just the equation of the tangent line. That should not be hard for you, right? That's all there is. So I can use this line to approximate a point on the curve. Maybe this point on the curve, it's not going to be exact, but it's going to be pretty close. And if I could make this equation better, like maybe adding in a squared term and a cubic term and a quartic term, I can actually approximate the curve incredibly well. That's called a Taylor polynomial, which is where we're going. It's the focus of the exam. Huge on the exam. And that's what we're going to chapter 8. We have a lot of preview work to do before that. Okay, so they call that the linearization. And notice they put that in this order. I prefer this order, and they prefer that order on the AP exam. But you could use, you could actually just use the original one we had here as well. And and how can you tell if you have an overestimate or underestimate? Yeah, looking at the concavity. So if you draw your curve and you draw your tangent line, here's the value where they touch. This is the value on the tangent line. This is the actual value. Is this an overestimate or underestimate? Under. And how do I know? Because we've done this. We did it last year, but we've done it this year too. What's true about the concavity? Concave up, so how do you know that it's an underestimate? Remember derivatives? F double prime is what? Greater than 0. I don't memorize it. I just figure it out. So what if it's an overestimate? We'll do some of those more more tomorrow, but we'll just approximate lines here. There it is. That's an overestimate. And so what is the second derivative? Is less than 0. There's your justification. Because they're going to ask you, is it an overestimate or underestimate? So that's really, it's not that difficult. You just find the concavity. And when I graded that, and there were some students that, they had no idea. Okay? So I want to write the equation of the line to this function. I'm sorry, I don't have directions there. And page 258, you know what? It's probably wrong. It's in your new book. I don't know what page it is, but it's in this section 3.9. Look at that matches. Okay, write the equation of the tangent line. They might call it linearization. Probably do. Okay, so, guys, what does e to the minus 2x look like? Grant, do you remember what it looks like?
I remember.
We do kind of need to know what that looks like. First off, I'd like to know if my answer is reasonable. Now, we know what e to the x looks like, right?
Yeah.
What does e to the minus x look like?
Flipped over the y-axis.
It's flipped over the y-axis.
Stretch. Or is that? Why'd you make it so?
Because I picked the wrong one.
I feel like that's thicker than usual.
It is. Because it's this one.
What's wrong?
Okay, we want the tangent line at a equals 0. Whoops. Okay. All right, question? Good. How are we going to do this? Now, as long as you are pretty close to a equal to 0, my tangent line is a pretty good approximation. The further you get away from this a equals 0, the worse it gets. Now, it's not too bad this direction, but this way, this is exponential. So that's getting steep really fast. So the difference between the approximation and the actual functions is going to increase quickly, but not so much over in this direction. And we are going to try to find out so that we're within a certain error. We want this distance to be a certain value, but that's the next couple problems. So I just want the equation of the line. So what's f of 0? No. What's f of 0? So it's e to the 0, 0, which is 1. So it goes through the ordered pair, 0, comma 1. Is that right? Okay. And what's f prime? What's f prime of x? We know this now. It's e to the negative 2x times negative 2 with the chain rule. And then we want to find f prime of 0. So it's equal to e to the 0 times negative 2. And what does this negative 2 do to the steepness of my graph, by the way? It should be making it steeper, I think. We could graph it. And so what's the equation of the line? I just write the equation of the line. It's y minus 1 equals negative 2, and it's x minus 0. And then we solve for y. That's our linearization. So it's 1 minus 2x. That's all there is. We could take a graphing calculator, and it should say that. It will look like this in your graphing calculator. You want me to do it? Minus 2x plus 1. This is the slope of the tangent line. It's the equation of the tangent line. L is equal to, really, the equation of the tangent line. Solve for y. Do you want me to do that on the calculator? We're going to have to use a calculator eventually anyway, but
Go for it.
have you seen that? I just think it's kind of cool. Because you guys know how to do that on your calculator? The tangent lines? Well, let's do it. I have one. I'm sorry, the other one's in my office. I forgot about it. Well, guess what? We have to change our mode back to function mode. And you know this is going to be on the test. So y equals, I'm going to clear that out, e to the negative 2x. Whoops. Zoom 4. There it is. And we want the tangent line at 0. So we go through second, draw, tangent line. I'm at 0, but if I didn't, okay, I'm going to try this. I think I can type it in. So let's say I wanted it at 1. I could just type in 1. And there it is. Y equals negative 2x plus 1. Yes, we'll do that again. Now, because I'm in the draw menu, if I want to clear that out, I have to actually clear it. If I try to graph it, it keeps the line there. So I'm going to go second and then draw, and I'm going to clear my drawing. And you could just write the equation of the tangent line by calculating the slope, but we are going to go to draw, second, draw, okay, and tangent line is 5. And if I wanted to do it at 1, I could type in 1. And I could do that, but I really don't want that. I want to clear that. I want to put it in at 0. And there you go. And actually, the expression for this, I think we should say it, is that this, because we're drawing the tangent line at 0, we're saying we're centering it at 0. At a equals 0. That's not going to make a lot of sense, but it's where you draw your tangent line. But later on, I'm going to use the same word, and I'm going to connect the two. It's going to be a while. But that's what we're doing. We could center it at 1. We could draw the tangent line at 1 if we wanted. Okay. I'm going to give you a problem to try. I don't know if that's the real problem out of this book, out of the old book. I don't remember. But it says y is equal to this function. I want to show that the tangent line approximation at a equals 0 is 1 minus 8x. Let's graph that anyway. Because do you have any idea what that looks like? Well, it looks like 1 over x to the 4th. Where's my calculator? So I have to slide this over because I can't remember what it is. Clear that out. So it's 1 divided by parentheses 1 plus. You have to have those parentheses or it's not going to work. 2x to the 4th. And because we're centered at the origin, I would like to zoom at 4 because we usually get nice numbers. Well, there it is. And you're going to be using your graphing calculator on this assignment. And we want to do this at 0, right? So should we draw our tangent line and see if I'm right? Do I do that right? So second, draw. Second, draw. I don't know what went wrong there for a second, but at 0. Now, I'm not sure I like my picture. Okay, I really want to be focused at 0. It says negative 8x plus 1, and that's what I'm claiming here, 1 minus 8x. So you have to do some derivatives, but I'd like to see that better. So why don't we change our x's from negative 1 to positive 1? Because that's really hard to see. Okay, now I have to go back and draw it again. I don't know why maybe they changed it on this. It used to be you had to clear it. That looks better. Okay, what do you have to have? What's the equation of a line? You know this. Y minus y1 equals m x minus x1. When you do the derivative of this, do you want to use the quotient rule or do you want to use the chain rule? I'd rather use the chain rule, but I don't care. So m is equal to the derivative of y with respect to x. And y, I'm going to rewrite it. I'm going to give you a chance to try it, though. See if you can get it. And you know what the answer is supposed to be, right? What's the answer supposed to be for slope? We should get, well, look at what it says. The book is claiming that that's the equation of the line. So what's the slope going to be? Negative 8. So why don't you try it? Somebody can come up and try it, too. And I'll work it out because then it's on the video and it's on the smart board. Okay, what's the y value? Y equals 1 over 1 plus 2 times 0 to the fourth. Oh, that was tough. What's that? 1. So I get y minus 1 equals my slope, and it's x minus 0. So y is equal to mx plus 1. So all I have to do is calculate my slope. That's it. Okay, so let's see. There's my derivative. So what's y prime? There's my function. I'm sorry. Negative 4. Remember the chain rule. 1 plus 2x to the what? It goes down. Negative 5. Because I didn't want to use the quotient rule. I prefer the chain rule. Times, and then the derivative of the inside function is 2. Remember, it's times. Then you're going to evaluate that at x equals 0. So it's negative 4. Kind of. Yeah. Actually, what they do on your, especially if you have the pretty print on your calculator, then it'll say x equals, box there, 0. How do I get what? It's at 0, so what's the slope? Negative 4 times 2 is negative 8. And I just put that right in here. Negative 8x plus 1, but that's the same as 1 minus 8x. No, that's not wrong. Oh, but the negative 4 is in the numerator. This goes in the denominator. That's what it is. Good. Okay. Now, is this the problem still? Oh, yeah, we're going to turn this over now. Now is the tricky part. Now, I'm going to go back to my picture. And this is the hard part, is getting the right window. So if you look at the back of your sheet, we have a new note, well, not new notation, but it's a notation that you might have some troubles with. Right here. But you know what's interesting, though, is that on the MCAs for grade 8 algebra, they have to know what to do with that, which I don't think is appropriate because I think it's hard. It's saying that the distance between my line, this is my line, and my function, the actual value of f of x, sorry, I want that distance to be less than 0.1. So if I go and look at my picture, and I want to redraw it, I'm just going to draw it by hand. So it's going to look, what does it look like? I'm just going to extend it here. And I'm going to draw a line. We're doing the back side here. I want the distance between the line and the curve, this distance to be less than 0.1. That's what I want to do. And the question is, what are the x values? Notice if as x gets bigger, what happens to this distance? It increases. So I want to limit myself so that this distance is going to be less than 0.1. Yes, because it's not symmetric. It's not symmetric. So that's going to be tough to do. But let's take this equation here, and let's solve this equation. So I have the absolute value of L minus F is less than 0.1. That's what I did in this line, but you may not see it. Now, do you remember how to solve an absolute value inequality? L minus F is going to be between 0.1 and negative 0.1. And then I'm going to solve this equation here for L. So I'm going to add f of x to both sides so that my linear approximation, L of x, is going to be between 0.1 plus f of x and 0.1, whoops, f of x, sorry, minus 0.1. I want to clean it up a little bit. F of x minus 0.1 is L is between f of x plus 0.1. Now, you're just going to look at, I want the line, I added f to every side, both sides, all three sides actually. It's a way to do it. You might find other ways to do it. There are other ways to do it. Could you just type this into your calculator and do it that way? Yes, you could. So if you want to get your calculators out, let's do this. It's going to be challenging to get the window. I'm almost there on my window, but not quite. So in y1, we're going to put this. Then it doesn't matter if it's y2 or y3. It doesn't matter. But you're going to do the function plus 0.1 and minus 0.1. And you're going to see where the lines intersect. I've got a picture right there. Let me see. Where's my, see if I can find my curve. No, I'm not going to look at the curve. This is the linear approximation. And this distance here, between the line and this, all these distances are always less than 0.1. So you need to find this x value and this x value. Let's just do it. Okay, let's get my window a little bit better. What is this? Negative 1/2? Where's my window? Let's make that negative 0.5. And let's make this positive 0.5. It might not be big enough, but let's look at it. Okay, now I have to put in my tangent line. I think I'm missing something there. Okay, so in y equals, I want to turn that off so it's not a thick line too. I don't know why when they clear it, that doesn't help. It doesn't clear it, but it doesn't. And I'm going to do the same thing to this one. Whoops. Okay, so I don't have my L in there for some reason. So in y2, let's do what I say. It's y1 plus 0.1. Oh, there it is. Now, if you have the new operating system, you can just go alpha calc, but I'm going to turn this on. And it's vars. Remember how to do this? y1. That's my function plus 0.1. I will turn that off because it gets to be too much. And then in y3, I do y1 minus 0.1. It doesn't matter, but I just want it to be the same. And then I'm going to turn this one off because I don't want to see this graph. But I'm not done yet because I need to graph the line, which I'm going to put in y4. And what's y4? 1 minus 8x? Is that what it was? It's kind of cool. Because that was my linear approximation from this problem. Remember when we did that? So that's this. So what I'm going to be doing is shifting this graph up a little bit, which doesn't intersect at all, and then down a little bit. And I need to find these x values. Sometimes, there's like 2 problems in the homework, but sometimes it's 1 point on the one that's below and 1 point on the one above, or vice versa. I don't ever know. You'll see when you do them. It'll just happen. Okay, and so now I'm going to graph that. I hope I've got a good picture. Oh, well, I'm in the middle of this. Wait. That's not a very good window, is it? Okay, I know I want just this piece here, so my x's are okay, but let's make my y's go from, oh, I don't like zoom fit. It doesn't work very well. Oh, zoom stat. Well, I'm not doing stats. Let's make this go from, we know it's positive, so let's make it go from 0 to 1. Or 1 and a half. I want to make sure I get everything. Because I don't remember what my window was last year. I'll put my window up there a second. There comes the other curve. Here goes my line. And I still don't like my window. I don't like zooming in either. box, you could box it. Let's make that 0.1. I just play with it. There's the curve. It's looking a little better. There's the other one. And now I'm going to get the line. Well, I think that's a lot better. Here's my window. So they're going to be little numbers. How many places must you have? 3. So there's only 2 problems in the homework, so I suggest you do them. I'll be honest, there's a test question on it. But I think it's with a partner. Now, why am I doing this? Why do I care? Because it helps us with Chapter 8. Maybe. Sure. Okay, so we want to find what? Where these intersect and where those intersect. Now, honestly, if I'm on an Inspire, it's probably a lot easier. So second, calculate. I haven't done it on Inspire, but done these problems. Now I want to see where these intersect, so I got to go down to the curve where they intersect. That's one of them. And then I got to make sure I'm on the other one where they intersect. And now I didn't really put a guess in there, but I'll let it just find the one itself. Okay, it found that one. So there's your answer. I would include all places, not just a couple. And then we're going to go second, calculate how do I get the other intersection point? Oops, wrong graph. And you're just going to have to do them. So I suggest we do them, you do them right now. But I got to get over to the other point. Come on. I could put a guess in there, but I don't really know what it is. So that's okay. There it is. Can I squeeze it in there? Then, if you choose an x between these 2 values, anywhere between these 2, the difference between the actual value of the function and the tangent line will be less than this error. You will see questions, I'm thinking of one in particular, in the multiple choice that might have you do something like this. Could you type this in directly? Sure. And it'll also work. This is just the way the textbook explains it. I don't care. So if you want to type in the absolute value of 1 minus 8x minus your function, fine. You can do it that way. I now remember the question. It's a Chapter 8 question. So what's x going to be between? It will be between, as long as my x values are between these 2 values, 0.055, just truncate, and 0.045. Then, sorry, that's negative. Then the difference between my approximation and my real value is going to be less than 1/10 away. So in other words, my error is very small. You want the error to be small. Now, do you guys want to try the homework problem together? Well, I don't know which one it is, but it's there. Or do you have questions on homework, any of the homeworks? Now we're spending 2 days. Tomorrow we'll get the second part of this in, which is what you've seen before. So this is new, and then you have a couple days of review, and I have a calendar someplace. I'll tell you which problems are like this. And there's some really good problems in here. And it's applied to physics. Okay, you jump around on these because number 9 is what I'm going to do tomorrow. Unless you want me to do everything today and be done. Oh, no, I can't. Oh, yes, I can. Number 12 is like this. 3.9 is where we're at. This was 13 that I just did. 14 is kind of like this, but we don't have the error on it. The error comes in, I'm trying to find it. It's okay. You can do it in order. So really you can do 1, 7, 9, 12, and 14. What's the accuracy ones? Oh, I think you have one homework problem. No, 12 and 14 you're going to do this with. Sorry. So you can get up through 14, and then tomorrow we'll do the 17, 19. And then we have a little homework quiz tomorrow. Oh, you're talking about the homework quiz. Multiply it out. 3.9.
People told me it's hard.
Oh, homework quiz tomorrow.
We do a quick.
3-3, 3-4.
We do a quick one.
No, I'll help you with it on your. No, I'm not gonna do that.
No, not give me an exact one on the quiz. Like
No, go back and look at your homework. It's a homework quiz.
I couldn't find it in the homework.
Oh, it's there. Should be there, unless I messed up. You know, that's always a possibility.